Right, I thought I'd give you another quick update, seeing as how I don't really have anybody else to update. But it's come along a bit, so I'll just go through this again. This is the stack pointer. So this is the latch that holds the value, and that's the switch that puts it onto the data bus. This is the data bus all along here, 8 bits. This is the program counter, so this is the switch that puts that on the data bus, or gets it from the data bus. It can load a value into the counter, so it counts with these two numbers, and if it needs to jump to somewhere else in the program, it can load it from the data bus. And then this is register 1, 2, 3, and 4. I decided to go with the ARM names rather than the Intel ABCD thing, mostly because I've also included these now, and this is an A register for the ALU, so that's the A operand, and then the B operand comes in on this bus. So I've actually got 3 buses: the main data bus, the A register data bus, and the B register data bus. Now basically what these do is the data that's loaded into the register comes into the ALU from this side, and since, for example, this one is connected to both that latch and that latch, it can either go into the A or the B. So I can load any register, 1, 2, 3, or 4, via the A or B operand bus. So the A bus doesn't really do anything. It comes in here, it'll do a carry, and it can, via this switch, be set to 0. But that's pretty much it. It either passes straight through into the adders, or it's a 0 and that's passed into the adder as well. So that's if you want to just add nothing to the B register, it can be a 0. And then this latch puts it back. This latches the value, this puts the value onto the data bus. Then all of this mess is the B register, and the B register is broken into 2. It does shift left, shift right, and this switch just passes it through unchanged. Or it can turn on these, which are logic control units, multiplexers, then it can do AND, OR, XOR, NOT, whatever. So if you wanted to XOR the value in B, you just turn it on, bring it in, it'll XOR it, and then you put it out onto the data bus for collection. So that's pretty much it at the moment. I've got this over here, which is my control system. So these are multiplexer. This one's 1 to 16, or 4 to 16. And this one's 3 to 8, 3 to 8, and 3 to 8. And then I got a EEPROM, which will do 16-bit addressing, so it'll control 16 control lines, and this one will control 16 control lines. But I still have to do the RAM chip, so I need to load RAM either here or here, and I need to have a RAM register as well, so that it can put the value of the RAM onto the bus. And after that, I also need a increment pointer, so I need to know the value of the next thing, like the program countered value in memory, all that sort of stuff. So where in memory am I supposed to pull this from? So I've got the memory register, but I also need the sort of IR register to work out which bit of memory I need to get. And then after that, it should, in theory, be just a matter of using it in Anchor, programming it to do stuff. I still haven't managed to get this working, which is the translator from binary to decimal. I attempted to do a similar sort of thing with a LCD screen, but that doesn't work, and neither does that one, and I'm not 100% sure why it doesn't. So more testing required there. Programming wise, I've started to load the C program that'll do the bit shifting and things to set up the microcode inside of these EEPROM chips that will load the op codes to run everything. So basically, you have an op code that says, you know, move value from register A, into register A bus from register 1 and B from register 2 and add them together. That op code should be handled by the microcontrol code in these two chips that say, well, that means you have to turn on this one and this one and that one and this one. Anyway, so that's it for the moment. It's a bit of a mess because I wired this logic thing up here and then I had to take it out and then I've had to rewire this, and I've rewired 2 or 3 sets of chips since the last time I did an update for you. But anyway, that's how it's going. Hope you're doing well. Talk to you later. Bye.